Hi, I'm Bill Hitchcock, and this is our second part of the number conversion videos. What we're going to be doing is converting from binary numbers to decimal numbers. So, for an example, if I have a number like this, normally we'd think of that as being 110. There's 1 in the hundreds place, 1 in the tens place, 0 ones, 100 plus 10 plus 0 equals 110. However, this could also be a binary number. All right, a binary number means that you just have two digits. They can either be zeros or ones. So all I can have in my binary numbers are just zeros and ones. Now I want to find out what that number is in terms of a quantity as a base 10 number. So in base 10, what we do is we'd multiply this by 10 to the 0, 10 to the first, 10 squared. But since this is a base 2 number, what we do is we take this and say that this is the 2 to the 0 column. Next to it, we have 2 to the first. Next to it, 2 squared, or 2 times 2. And so on. 2 cubed, 2 to the fourth, 2 to the fifth, and so on. Well, I really don't need to carry these out that far because I don't have digits in those. Those would just be zeros, so they're kind of irrelevant in this case. So let's do the math. 2 to the 0, well, remember, x to the 0 always equals 1, so it doesn't matter what it is. In this case, 2 to the 0 is 1. That's the ones place. 2 to the first is 2. 2 squared is 2 times 2, 4. And if we had to carry this out farther, 2 times 2 times 2, or 4 times 2, however you want to think of it, is the eights column. 2 to the fourth is 2 times 2 times 2 times 2, 4 times. That's 16. Double that, or 2 times 2, 5 times, is 32's column. And again, these are kind of irrelevant in here because we don't have any digits on there. So now what I do is I take my digits, 110, multiply them by these factors of 2. So 0 times 1 equals 0, plus 1 times 2 is 2, plus 1 times 4 is 4. 4 plus 2 plus 0 equals 6, and there's my answer. All right, so let's try another number and see how that works. Say if I had a number like 1, 0, 1, 1, 1, base 2, and I want to find out again, what does that equal as a decimal number or base 10 number? So we start out 2 to the 0, 2 to the first. You always start in your rightmost column, 2 to the 0, the ones place, 2 to the first, 2 squared, 2 cubed, 2 to the fourth. 2 to the 0 is 1. That's 2. That's 4. That's 8. That's 16. And then we go ahead and multiply each of these. So 1 times 1 is 1, plus 2, plus 4, plus 0 times 8 is 0, plus 16. So let's see, 16 plus 4 is 20, plus 2 plus 1 is 3. That equals 23, and there's our answer. So just for a quick hint, if the rightmost digit is 0, in this case it was 0, you know you should end up with an even number. If it's 1, you're always going to end up with an odd number. So in this case it was 1, and hence I have an odd number. 23 is my answer. So that's another way that you can sometimes kind of just check your results and see what happens. So let's just do one more quick example and we'll give this a try. 1, 1, 0, 1, 0, 1, base 2. We want to find out what does that equal as a base 10 number. It's 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth. The ones column, the twos column, the fours column, the eights column, the 16s, and the 32. Each time I'm just multiplying those by 2 is another way of doing it. Or if you want, just do the 2 times 2 times 2 times 2. You'll find it's a lot easier just to take the previous number and multiply by 2. We multiply all this out. 1 times 1 is 1. 0 times 2 is 0. 1 times 4 is 4. 0 times 8 is 0. 1 times 16 is 16. 1 times 32 is 32. And let's group some of our numbers just to make the math a little bit easier. 16 plus 4 is 20. Plus 32 would give me 52. Plus this 0 plus 1 is 1. So I've got 53. And again, because this ended in a 1, we've got a odd number, and we ended up with 53. Now, if you want to test all this stuff out, it's pretty easy just to go in, Google binary to decimal calculator, something like that, or number-based calculator, and you can find some calculators, all right? And that's a great way to find out if you're getting the right answers. But I want you to understand this math that we're doing, because it's all about understanding the logic, how we take these numbers, multiply them by powers, add them all together. It's that process that we're trying to develop here. And the other thing too is the fact that the reason why we're using binary is that's what the basis of all computers run on. It's all digital. It's all a series of ones and zeros. So if you can understand this concept of working in ones and zeros, you can see a little bit more into the underneath about how computers work. So give it a try. Try out some of your own examples. We're going to come back and do a few more things with number bases, but there's a good start.